When we contemplate the existence of intelligent life, our collective imagination invariably turns upward, casting its gaze toward the vast, silent tapestry of space. We listen for signals with radio telescopes, we scan distant atmospheres for biosignatures, and we dream of missions to Mars, Europa, and exoplanets orbiting faraway stars. The search for extraterrestrial intelligence, SETI, is, by its nature, a search across the spatial dimension. But this search, in its singular focus on out there, often overlooks an equally vast, unexplored, and profoundly disorienting dimension, the expanse of deep time. We inhabit a planet that is 4.5 billion years old. Complex life has been present for over 500 million of those years. We, as an industrial species, have existed for a mere 300. This is a statistical whisper, a fleeting instant in the planet's biography. This temporal gulf is so immense that it forces a startling question. Could Earth itself have hosted other civilizations long before our own? Is it possible that indigenous technological species arose, flourished, and then perished, their entire history now buried, lost, and compressed deep beneath our feet? This is not the realm of fantasy. It is a formal scientific thought experiment known as the Silurian Hypothesis, famously proposed by astrophysicist Adam Frank and NASA climate scientist Gavin Schmidt. Named after the ancient Doctor Who aliens, the hypothesis asks a simple, terrifying question. If an industrial civilization existed, say, 100 million years ago, what trace, if any, would be left for us to find today? The answer is almost certainly not what you think. There would be no statues, no steel skeletons of skyscrapers, no silicon chips. The true search for our predecessors would not be a matter of archaeology, but of geology. We would be searching for a ghost in the rock, the great erasure, the challenge of deep time. The primary obstacle in this search is grasping the sheer, annihilating scale of geological time. Life, in some form, has existed on our planet for approximately 4 billion years. For the vast majority of that history, it was simple, single-celled, and microbial. Then, around 540 million years ago, the Cambrian explosion heralded the age of complex, multicellular animals. This event opened an enormous time window, a half-billion-year stage, for a non-human civilization to potentially emerge, evolve, and die. But the planet itself is a relentless recycling machine. The Earth's surface is not a static museum. It is a dynamically active, chaotic engine. The doctrine of uniformitarianism, the idea that the present is the key to the past, shows us that the forces of erosion, tectonic subduction, and sedimentation are constantly destroying and reworking the planet's crust. Plate tectonics means that the ocean floor is completely recycled, every 200 million years or so, pulled back into the molten mantle. The continents we live on are eroded by wind, water, and ice, with their detritus washed into the sea to form new sedimentary rock. Entire mountain ranges are ground down to dust. When we search for ancient human history, we are talking about a few thousand years. But in deep time, this is nothing. What is the oldest large-scale surface on Earth? It's not a continent. It's a small patch of desert in the Negev, a mere 1.8 million years old. Everything older than that has been crushed by pressure, melted by the mantle, buried by kilometers of sediment, or scoured away by glaciers. Our own industrial age, this period we have triumphantly, or ominously, named the Anthropocene, will be geologically fleeting. After a few million years, all of our cities, monuments, and infrastructure will likely compress into a single, anomalous layer of strata, perhaps only a few centimeters thick. To find a similar civilization from 100 million years ago, we would need to find their lair. To understand what we could find, we must analyze the only data point we have, ourselves. Human history, though brief, provides a model for the 3 distinct types of civilizational footprint we might search for. Phase 1. The pre-agricultural signal, hunter-gatherers. Anatomically modern humans, Homo sapiens, have existed for about 300,000 years. For a staggering 97% of that time, roughly 290,000 years, we lived as small, nomadic groups of hunter-gatherers. We know that other intelligent, non-sapiens hominins existed during this period, such as the Neanderthals and the Denisovans, species capable of complex tools, symbolic art, and, likely, language. What traces did they leave? Only the very sparsest. Fossilized bone fragments, simple stone lithic tools, and the occasional handprint of ochre on a cave wall. The likelihood of detecting such a civilization from deep time is extremely statistically low. The process of fossilization, taphonomy, is incredibly rare. To become a fossil, an organism must die in a very specific location, like a river estuary or bog, be buried rapidly by anoxic, oxygen-poor sediment, and remain undisturbed for millions of years as its organic matter is slowly replaced by minerals. The vast majority of organisms are eaten, scattered, or simply rot away. A species could exist for 100,000 years, and we might only recover a mere handful of bone fragments or nothing at all. Their artifacts, being largely organic, wood, fiber, hide, would simply biodegrade and disappear completely. Even their simple stone tools, the most durable of their creations, would be problematic. After 100 million years of being tumbled, crushed, and chemically altered, how would a future geologist distinguish a primitive stone chopper from a naturally fractured rock, or geofact? If a non-hominin, intelligent species existed, say, a tool-using dinosaur, or a hyper-evolved cephalopod, their non-lithic artifacts would stand zero chance of survival. The signal is effectively noise. Phase 2. The agricultural signal, empires, and monuments. Roughly 10,000 years ago, the agricultural revolution completely transformed human society. This phase allowed for specialization, massive population growth, and the construction of cities and monuments. These societies undeniably left a much stronger, more permanent signal on the planet. They produced sophisticated artifacts from durable materials like pottery, fired ceramic, metals, and glass. Most impressively, they built massive stone structures. The Great Pyramids of Egypt, for example, are essentially artificial mountains built of native limestone. Because they are so massive and geologically stable, they will likely persist as a recognizable, anomalous shape for hundreds of thousands, perhaps even a few million, years. Because of this, we can look at the recent geological past, the last few million years, and say with very high confidence that no such agricultural civilization existed. We would have found their fossils, now in the millions, their ceramic artifacts, or the monumental ruins of their cities. We have found nothing. But in deep time, tens or hundreds of millions of years, this signal also vanishes. The pyramids will eventually be ground to dust by erosion or subducted. Their tools and advanced metals would corrode, oxidize, and dissolve, returning to the earth as ore seams. Their traces would eventually become completely indistinguishable from natural sedimentary layers. A 100 million-year-old city would just be a slightly odd layer of compressed rubble. Phase 3. The industrial signal, the technosignature. This brings us to our own unique footprint. For only the last 300 years, a mere 0.1% of our history, humanity has been an industrial species. Our impact on the planet during this time is orders of magnitude greater and chemically different than all that came before. If our civilization were to vanish today, we would leave a distinct and lasting geological technosignature. This signature would not be our cities or skyscrapers. Built of steel and glass, they are chemically unstable. They would rust, crumble, and be overgrown in millennia, eventually becoming a thin layer of rubble. Instead, our signal would be a sudden, anomalous chemical spike in the geological strata, a global golden spike that would be visible for hundreds of millions of years. This technosignature would be defined by several key markers. Isotopic anomaly. For 300 years, We have burned fossil fuels, ancient, C12-rich plant matter. By spren, releasing this carbon, we are rapidly and globally altering the C12, C13 isotope ratio in the atmosphere and oceans. This Suez effect is a blatant, unnatural fingerprint. Transuranic elements. The plutonium, Pu-239, from our nuclear testing and energy programs, has zero natural occurrence. It has a half-life of 24,100 years. After a few million years, the plutonium itself would be gone, but it would have decayed into a unique and anomalous concentration of its daughter products, like uranium-235, that geologists would instantly recognize as unnatural. Synthetic polymers. We have created entirely novel, complex, long-chain hydrocarbon molecules that do not exist in nature. These plastics are now being deposited in sediments worldwide. It is highly likely they will fossilize, creating a plastic conglomerate layer, a bizarre hydrocarbon seam that screams artificial. The nitrogen cycle. Our industrial fertilizers, via the Haber-Bosch process, are now fixing more atmospheric nitrogen than all of Earth's natural processes combined. This unprecedented deluge of nitrogen is altering ocean chemistry and will be preserved as a massive spike in nitrogen isotopes like N15 in marine sediments. The fossil record. We are the asteroid. We are engineering a mass extinction of global wildlife. This extinction would coincide with an explosive, planetary-wide radiation of our commensal species. The fossils of domesticated cows, pigs, chickens, and of course, rats, would suddenly be found on every continent. The search, the paradox, and the sobering conclusion. This, then, is the real signal. The likelihood of detecting this chemical technosignature is the most promising of all. A layer like this would be clearly detectable for hundreds of millions of years. And yet, to date, scientists examining the geological record have found no such anomalous layer. We certainly see evidence of past mass extinctions and massive climate shifts. The most famous is the KPG boundary, 66 million years ago, which wiped out the dinosaurs. But its chemical signature is of an asteroid, a spike in iridium, not plutonium or plastics. The best analogy for our current event is the Paleocene-Eocene thermal maximum, 56 million years ago. It saw a massive natural carbon release, global warming, and ocean acidification. But this event, while rapid, still took place over thousands of years. Ours is taking place over hundreds. This null result leads to a fascinating and perhaps tragic paradox of sustainability. A highly destructive, fossil fuel burning civilization, like our own, so far, leaves a very strong, visible, and anomalous technosignature. However, by its very nature, it may be wildly unsustainable and cause its own extinction rapidly, lasting perhaps only a few centuries or millennia. This is an impossibly narrow target to find in 500 million years of geological history. A future geologist could easily miss the single, paper-thin layer. Conversely, a truly sustainable, advanced industrial civilization might last for millions of years, but to be sustainable, it would have a minimal impact. It would recycle all its resources, use clean energy like fusion or solar, and create only biodegradable materials. Its geological footprint would be so subtle, so clean, that it might be completely invisible and indistinguishable from a natural ecosystem. So, we are left with a profound, and perhaps lonely, conclusion. While the concept of a lost terrestrial civilization is captivating, all available scientific evidence points to a null result. It seems the vastness of deep time, just like the vastness of space, is silent and empty. As of today, we have found no discernible traces of indigenous aliens in the geological record. This conclusion, however, is not the point of the hypothesis. The true value of the Silurian hypothesis is not that it helps us find others. It is that it helps us find ourselves. It provides a mirror, forcing us to see our own civilization from a truly alien perspective, that of deep time. The very act of searching for these signatures helps us refine our understanding of our own planetary impact. It highlights the profound, and perhaps permanent, chemical mark we are currently, and rapidly, leaving on planet Earth. The most important takeaway from this thought experiment is a deeply sobering one. The geological record clearly shows that while life itself is incredibly resilient, complex civilizations may not be. They appear to be, by their very nature, extraordinarily fragile. This implies that our own continuation as a civilization is not guaranteed. If we are not careful, we may one day be nothing more than that thin, anomalous layer of strata. A layer of plastic, isotopes, and rat bones, waiting to be discovered by the next civilization, or perhaps by the first. Thanks for watching. Don't forget to subscribe so you don't miss any videos. See you soon.